Here we have Slim Jim, who's pulling with 80 newtons, an 80 Newton force, on a 12 kilogram object, so that is the mass of this box, across the floor with an acceleration of -3 meters per second squared. So since our acceleration is negative, we know it's accelerating to the left. There is a friction between the box and the floor. So first it asks, what is its acceleration? Well, that's easy. It gives it to us. Our acceleration is -3 meters per second squared. Alright. And now it wants us to draw the forces on the box. So let's think about everything that we've got here. It's on Earth. It's going to have the force of weight. Right? It's also going to have a normal force. And it tells us that the surface and the box have friction. So we'll have our frictional force. And we also have the applied force that Slim Jim is using to pull the box. So here we have our force of weight. Here we have our frictional force. And actually, this is a very specific type of frictional force. Since it's moving, we know that it's kinetic friction. So we'll put Fk. Alright, this is the normal force. And then we have the applied force. We'll just call that Fa. Okay. Now that we've drawn our forces, in the x direction only, use the sum of the forces equals mass times acceleration to find the force of friction on the box. Well, the sum of the forces in the x direction are equal to Fk, which is going to the right, so that's going to be positive Fk. And then the applied force, which is to the left, so it's going to be negative. We're going to be subtracting our applied force. And that equals mass times acceleration. So we have our kinetic friction minus our applied force of 80 newtons equals our mass, which is 12 kilograms, times our acceleration, which is -3. I'll clean that up a bit. Okay. -3 meters per second squared. So whenever we multiply 12 and -3, you should get -36. So we're going to have a kinetic frictional force minus 80 that equals -36. Then we are going to add 80 to both sides. So 80 minus -36. And we get 80 minus 36 is 44. So our kinetic frictional force is 44 newtons to the right. Alright, since it is moving, did you find static or kinetic friction? We found kinetic friction. And how much normal force is acting on the object? Well, the normal force is going to be equal and opposite to the force of weight because we have no additional forces in the y direction. So if the force of weight is mass, which is 12, times gravity, which is 9.8, then our force of weight equals 117.6. And since it's a force of weight, this is newtons down. Well, we want the normal force. So if the force of weight is 117.6 newtons down, we know the normal force is going to be 117.6 newtons up. Right? So that's our normal force right here. Alright, write the equation for friction. We know that kinetic friction, Fk, is equal to mu k, the kinetic friction coefficient, times the normal force. So here it wants us to calculate the coefficient of friction. So our kinetic frictional force is 44 newtons, and we have a friction coefficient that we're trying to solve for being multiplied by the normal force, which is 117.6 newtons. Alright, newtons over newtons create, they cancel each other out, so your kinetic friction coefficient is actually not going to have units. So to solve for the coefficient, you divide both sides by 117.6. This here cancels out. These newtons cancel out. And then your kinetic friction coefficient is equal to 44 over 117.6 to 44 over 117.6. So our coefficient is 0.37, which is kind of high. The friction coefficient is from 0 to 1, depending on how rough or smooth it is. The higher the number, the more rough a surface is. So our kinetic friction coefficient is 0.37 here.